right, so continuing our discussion about trigonometric functions for any angle. On page 507, there's a table that I would probably put on my formula sheet, and it talks about the value for the trig functions at any angle theta. So again, don't forget, we've been talking only about acute angles up to this point. Now we're going to talk about angles of any measure. All right, so we figure out our trig functions for any angle by considering a reference triangle and a circle. Okay? If we have any angle, my circles are not that great, so bear with me. So we have a circle. We have some sort of reference angle that starts with its initial side on the x-axis and some terminal side as the radius of a circle. What we can do is construct a right triangle, okay? So it doesn't matter where your terminal side is, you can always construct a reference angle, okay, from the x-axis. Now, what it's important to remember is that this terminal side is the hypotenuse of a triangle. We're going to call it R because it's also the radius of a circle. And the point that this terminal angle ends, we're going to call it some point, has an x and y coordinate. It has some sort of x coordinate and some sort of y coordinate. Okay? So when you look at this table on page 507, that's where all the x's and y's come from. They're coming from the coordinates of a particular terminal angle. It's probably a good idea to look at the pictures on page 507 and 508 of all the different circles. On page 507, it gives you a number of pictures of how to construct your triangle from the circle. On page 508, what's important are the quadrants and the signs of your x and y coordinates within each quadrant. If you remember way back from algebra, this is your first quadrant, your second quadrant, your third, and your fourth quadrant. And any coordinate in this quadrant is going to have a positive x and a positive y. Any coordinate in this quadrant will have a negative x and a positive y. Any coordinate in this quadrant will have a negative x and negative y, and this quadrant will have a positive x and a negative y. That's going to be important when we start putting together our trig functions for angles of any measure in any quadrant, okay? It's also important to note that the radius of the circle, also called the hypotenuse of the triangle, is always positive. Okay? Your hypotenuse is always positive, your radius is always positive. That's because if you recall the Pythagorean theorem, x squared plus y squared is going to equal c squared, or actually it's called r for radius. So when we find the radius, it's squared. We have to square this or take the square root of this, and you can't take the square root of a negative number, so radius is always positive. Okay? So let's look at an example. Maybe, let's look at an example. Okay. Find the 6 trig values for the angle. For the angles shown. So if we have a picture, let's look just briefly at one of them here. There are a number of other examples in the text that's probably worthwhile to take a look at. So we have some terminal side here of an angle that looks like this. It's a positive angle, it goes counterclockwise, but the coordinates of this point here are -4, -3, which means, I'm going to erase the angle here, which means that if we construct a right triangle here, our x coordinate is -4, our y coordinate is -3. So, looking at our 6 trig values, and we're pulling just the formula from that table on page 507, first of all, the sine of theta is going to be y over r. Well, it looks to me that before we can plug anything in, we need to figure out what the radius actually is. So your radius is going to be x squared plus y squared. In this particular case, our radius is going to be -4 squared plus -3 squared. 16 plus 9, 25. And of course, you take the square root of both sides, so the radius is actually 5. Again, it's positive because we had to take the square root. You can only take the square root of a positive number, so the radius is 5. So if we want the sine of that angle, this angle that kind of swings all the way around here, it's going to be our y value, which is -3, divided by our r, which is 5. So it's -3/5. I believe you can just leave it like that. Yeah, you can just leave it like that. Our cosine value, our cosine of theta is x over r. In this particular case, our x coordinate is -4, radius is still 5. You can leave it as 4/5. Tangent of theta is going to be y over x. In this case, our y is -3 divided by x, which is -4. That simplifies to positive 3/4. Cosecant is r over y. In this particular case, it's just going to be the inverse, 5 over -3. Secant of theta is going to be r over x. It's, again, just the inverse of this, so 5 divided by -4. And then cotangent of theta is just the inverse of this, which is positive 4/3. So, as you can see, it's probably pretty important to make sure that you write stuff like this, these formulas down on your formula sheet for the exam. Again, there are a number of other examples. It's probably a good idea to look at those. And that should wrap it up for this week.